Welcome to the Minnesota Rovers Tuesday evening presentation. Minnesota Rovers is an outdoors club based in Minneapolis, St. Paul. Our members organize trips that range from 1 hour to 2 weeks in Minnesota or further afield. Examples of our activities include hiking, biking, backpacking, skiing, snowshoeing, paddling, and rock climbing. We also organize conservation and trail clearing trips. Our members have experience and skills in many outdoor activities, so if you want to learn a new outdoor activity, we can probably help you. For more information, go to mnrovers.org. Now let's move on to this week's presentation.
Tonight, you're here for Tour the Evening Planets with Bob King, aka Astro Bob. Our presenter, Bob King, fell in love with the night sky and astronomy when he was a kid and loves to share his passion with people of all ages. Bob writes the Explore the Night column and Celestial Calendar for Sky and Telescope, teaches community education astronomy in Duluth, and pens the Astro Bob blog. Latest book, Magnificent Aurora, is a comprehensive guide to the Northern Lights. He lives in Duluth, Minnesota with his family and enjoys classical music and hiking. So please welcome tonight's speaker, Bob King.
Thank you very much, Stacy. I appreciate that. Just sitting here on a wonderful night in Duluth, and we're going to be doing some roving tonight off planet, as I guess that's what I normally do, is off planet. And we're going to talk about the other planets. And I might just sneak in one in the morning sky too, even though the title of the presentation has to do with the evening planets. So with that, we'll go directly to our presentation this evening. And I will share that with you in just a moment. We've got all the planets, kind of the classic solar system diagram, which, by the way, is very misleading. The planets at this scale would be the size of dust, but then you wouldn't be able to see them very clearly. There's so much space between those planets compared to how big they really are. So if you could actually see the solar system, you wouldn't see spheres. You would just see these tiny bright dots strung out from the sun. And they are in that familiar order we all learned when we were kids. We have the innermost planet, Mercury, Venus, Earth, and then we've got Mars, just the next planet beyond the Earth. Then we move into the outer solar system with the gas giants. We have Jupiter here, and then Saturn with its beautiful rings. Uranus, it also has a ring and it spins on its side. That's why it looks a bit peculiar there. It's really a standout in our solar system for having such a strange tilt. And finally, the eighth planet, Neptune. And I'm going to switch over to give you an idea of how big the planets are. These are correct relative sizes of the planets. So you can see that Jupiter is just a big bouncing beach ball of a planet, and Saturn is too. And then the planets Uranus and Neptune, they're fairly large as well. They're about 4 times the size of our Earth. And Earth is this little rocky ball down here, beautiful marble. And next to it is Mars, which is about half the size, and then Mercury. Venus and Earth are very nearly the same size, Venus being just a little bit smaller. So there you get an idea. We have kind of the planets separated out into these gas and ice giants in the outer solar system where it's very cold. And then we have these little rocky planets that are close to the sun. Everything starts in the universe, and in particular in our solar system, with the most basic ingredient in the universe, which is dust. And the planets all form from dust from previous generations of stars. To get that dust into space, the stars evolved the complex compounds that the dust is made of, and then they exploded or otherwise released that material into space. So I've got a supernova explosion for you here, which should be happening right about now. It's just a little demonstration of what happens when a star comes to the end of its life. It collapses within its interior, explodes, and that material condenses in space into dust particles. That dust can regather. Sometimes it's a shock wave that comes from another supernova explosion that compresses the dust. And it forms this thing, in our case, called the solar nebula. 5 billion years ago, this whole place was nothing but very fine dust, very simple materials. There was water ice, there was iron and nickel and silicates like you see in the rocks today, but it was all in the form of dust. It gradually collapsed, though, where the matter was thicker, denser. Gravity pulled it together and collapsed it. And so it became denser. And as the collapse continued, that dust cloud began to spin. And that's why I've got our ice skater here in the middle. She's demonstrating that as you spin faster, or as you pull your arms in, I should say, you spin faster and faster and faster. Well, the same thing happened with that nebula, the original solar system. It spun faster. The densest dust formed the sun in the middle. That's where gravity pulled hardest. And the rest of the material spread out to form a disk because as it collapsed, it spun faster and faster and spread. It's a cloud, so it's very flexible. Within the disk, little eddies formed. Here you can see in stage 3 of the planet formation. And that material gravitationally came together to form the planets. And we are right now about 5 billion years later, just really practically an unimaginable amount of time, really, at the present solar system where we have the sun in the center, and then around it, the planets, plus all of the other things that make our solar system so fascinating. We've got comets, we've got asteroids, and each planet has its own personality and set of characteristics. This is kind of a simplified diagram, but it shows you the sun again at the center, the planets orbiting the sun. Planets that are closest to the sun feel its pull most strongly, and so they orbit more rapidly than planets that are farther away. So, for instance, Mercury only takes 88 days to go around the sun, whereas our planet takes 365, and Jupiter takes 12 years to go around the sun. They all orbit in roughly the same flat plane. And so as we look at them in the sky, they cycle in front of the background stars, the same group of background stars as they circle around the sun. And that particular group of background stars is divided into 12 constellations, the 12 constellations of the zodiac that you'll read about in the horoscopes, Leo and Virgo, Libra and Scorpius and so on. That's where they come from because that is your theatrical backdrop, as it were, for the motions of the planets as they revolve in that flat plane projected against the sky around the sun. Here's a view of the early evening planets. And I bet some of you have already been out looking at some of these planets. I bet all of you have seen the planet Venus in the west and Jupiter in the east. But this is kind of a view of where the planets are right now. The three bright ones that are first out when it first gets dark at around 6 o'clock in the evening. You've got Venus off to the right, which is in the southwestern sky. And then Saturn is in kind of in the southwest, but higher up in the southwest in the constellation of Aquarius. And way over in the eastern sky, if you turn your back towards the sunset direction, you'll see this really bright star coming up, and that's the planet Jupiter in Taurus, Taurus the Bull. And Jupiter is not far from two really pretty clusters. You've got a group here that's kind of V-shaped called the Hyades, and there's a bright star, a star in there called Aldebaran. And then up here in the shoulder of the bull is the Pleiades star cluster, also called the Seven Sisters. Now, they just look like bright stars to our eyes, and that's all the ancient people saw until 1608, when the telescope was invented and people first began to point them at these bright objects. And when they did, they discovered that, oh, they're not just points of light, but the ones that are moving around the sky with cycles that people have been familiar with for thousands of years. These are worlds. They're kind of like our own Earth. Each one looks a little different. looks a little different size, a different color, and has different characteristics. So I blew these up 400 times so we could see kind of what Jupiter looks like in an average telescope nowadays. It has these dark bands on it that sort of remind me of like an Oreo cookie. You've got the two dark chocolate layers on top with the cream filling in the middle, and Saturn with its beautiful ring. And you can see off to the right that Venus looks like the moon in a way. It goes through phases just like the moon. And we'll learn about those in just a moment. Here's Venus at dusk. This is in Duluth. I went down to Brighton Beach in Duluth not too long ago, last month, and photographed just this brilliant star at dusk. It's the only really bright star visible in the evening sky towards the southwest. And Venus is gorgeous. It is the brightest of the planets. And its name, what it is, what it means, goes back to Roman mythology. It's the goddess of beauty, the goddess of love. Venus has phases, like you saw in that other image, and it does because it's an inner planet. So when we look towards Venus, we see it orbiting around the sun. When it's off to the left side of the sun, which means it's to the east from our point of view, we see it not wax, but wane from full phase towards half. And then as it cycles in front of us, it nearly lines up with the sun and then appears to be a crescent, swings to the other side, and the other side of the crescent becomes visible, goes half again, and then back around to full. When it's to the left or east of the sun, and we look at Venus, it's in the evening sky. And when Venus passes right between us and the sun, after that, it moves into the morning sky. So sometimes we refer to Venus as the morning star and the evening star. And you can see the reason why. It's just swinging from one side of the sun to the other as it orbits around the sun. And we get to look in on it because we're farther away from the sun. Venus is also the same as the Greek goddess of love and beauty, Aphrodite. And of course, the name Venus comes to us from Roman mythology. This is, I think it's a 4th or 5th century bust showing Venus. And yes, very beautiful. But there's a really strange irony about this planet. It is very beautiful to the eye, and it's very similar in size to the Earth, but it is a hellish place. The actual planet itself, beauty to the eye. To be there, you would be in one of the worst environments that you could ever think of, one of the most dangerous places in the solar system. It has 85,000, more than 85,000 volcanoes. Some of them are likely still active. It's covered in clouds perpetually. There's no looking at any stars from the surface of Venus, this rocky planet. Perpetual overcast. And the overcast is not made up of water clouds, but rather sulfuric acid droplets. The atmosphere is almost pure carbon dioxide. So that traps, along with the sulfuric acid, that traps a lot of heat. So that has heated up the planet to the point where its surface temperature is 870 degrees. So it is a very hellish place. It's heavenly to look at, but just a very toxic environment to be there. We have not landed any spacecraft on Venus, but the Russians have back in the 1980s. And when they did, the average length of time those spacecraft could survive on the surface was on the order of 1 to 2 hours. And then they were fried, literally fried, and pressurized from that powerfully dense atmosphere. Here are some photographs. Even though Venus has clouds, we've sent spacecraft there that use radar to penetrate the clouds, and we've mapped the surface. That's why we know there are so many volcanoes on the planets. And here on the planet, here's one of them, Mat Mons, and another is Sapis Mons. And then these big yellow patches here are lava flows. So it's likely still active. Actually, we have seen some active volcanic vents, but it was definitely very active long ago when more of these things were erupting. Here's a view of the surface of Venus, which reminds me a lot of Duluth when I go down to the shore and I'm walking on the rocks. And no surprise, it's made of basalt, the same volcanic type rock created from and issuing from volcanoes that, solidifies into this dark, hard surface. In the foreground here at the bottom, you can see part of the lander, the Venera lander. This is, I believe, Venera 16. So what's the deal? Why is Venus so hot? Why does it have clouds that are made out of sulfuric acid? What makes this such a radically different planet when it's about the same size as the Earth? Well, it comes down, as far as we know, to one simple thing. It's a lot closer to the sun than we are. Close enough so that it got hotter than the Earth. And in its early history, the greenhouse effect was very important, and it didn't equalize or normalize. It was a runaway greenhouse effect, kind of a positive feedback loop that happened on Venus to the point where it increased the temperature and the cloudiness and the carbon dioxide atmosphere to the suffocating hot planet it is today. And the greenhouse effect, just to go over really quick here, certain gases, notably carbon dioxide and water vapor and methane, they trap some of the heat from the sun, which is good, helps to keep our planet warm. Too much of it, of course, can keep raising the temperature with some ill effects. So we get the sun, hits the earth, reflects back off into space, and some of those gases. And they've been very helpful to our planet over its history because they've kept it warmer than it otherwise might be. Venus likely started out kind of like the early Earth, with shallow oceans the first couple billion years of its history, but it was a lot closer to the sun. That extra heating evaporated the water, which went up into the atmosphere. Water vapor is a great greenhouse gas, so that increased the temperature, and then that evaporated more water. So the temperature went up and up and up and up until we think the oceans evaporated. Meanwhile, the volcanoes were pumping out CO2 and sulfuric gases, filling up the atmosphere. Over time, that intense sunlight, evaporating oceans, the trapping of heat through the volcanic activity and water vapor eventually created this hostile planet that to this day still looks like the most beautiful sight you'll ever see in the evening sky, that beautiful white gem sitting there in the deep blue. And the moon sometimes joins Venus. When you're out looking at Venus, often it's just by itself, but the moon, which cycles through the same part of the sky as the planets, but it does so in under a month, the moon will pass right underneath the planet on Wednesday. So that's tomorrow evening. So if it's clear, partly cloudy tomorrow evening, you can go out and see that really pretty crescent with a brilliant Venus right above it, starting about 45 minutes after sunset, maybe up to an hour and 15 minutes after sunset. And I'd bring your smartphone because you might be able to, because you've got enough light in twilight to compose a picture that shows those two beautiful celestial objects with a favorite scene. The next planet that's up, and this is up and to the left of Venus, is the planet Saturn. So it's up in the southwestern sky, but quite a bit higher. So if you look southwest, as soon as it gets dark around 6 o'clock, you'll see two stars up there. The top one is brighter, and that's the planet. And down below it is a star in the constellation of the Southern Fish called Fomalhaut. So Saturn's the upper one. It's in Aquarius, and it is quite far from Earth compared to Venus and quite a bit larger. It's about 9 times the size of our lovely blue planet. It has clouds too. There's no solid surface here. Just like Venus, it's covered in clouds. But the clouds here at this great distance are made of ammonia ice crystals, which are very common in the outer part of the solar system. Very low temperatures allow these very cold things to form ice and clouds. 146 moons, which is right now the current record for moons in the solar system for a planet. That's a heck of a big family. And of course, it is the Lord of the Rings. This is a Hubble Space Telescope image that shows the globe of Saturn surrounded by that absolutely spectacular ring. You might wonder, what do you need to see that? Just a small telescope, like one maybe about this big around, and a magnification around 50 times will easily show you the little globe and then the ring of Saturn. and a couple moons too. If you could get right in there, you would discover, and this is just an illustration, but if you could get right into the rings, like get on a spacecraft and shoot right in there, you would see that the particles that make up the rings, they look smooth from far away because it all blends together, but they're actually made up of billions of tiny objects. You could call them moonlets in a sense. Some are sand grain size, some are whatever, 30 feet across, pretty big, kind of as big as the living room and the bedroom here. The interesting thing about it, the rings are 170,000 miles across, which is about 2/3 of the way to the moon, but they're only 30 feet thick, which is super thin compared to how big they are. And they're mostly made of water ice, which is why they're very reflective and easy to see in a telescope. We don't know exactly why Saturn has rings, but it's likely that it's the result of some catastrophic collision of two moons or a comet and a moon that broke it apart into many pieces and that spread out to form this beautiful system of rings. Saturn's rings tip at varying angles because the planet's axis is tilted, kind of like the Earth's axis is. And as Saturn goes around the sun, sometimes we see the open north face of the rings, and then we see them edge on, and then we see the south face, and then the cycle repeats. Coming up in March of next year, the rings will be edge on. And when they're edge on to us, remember I said they're only 30 to 300 feet thick? When they're edge on at that distance, they completely disappear for a few days. I have seen Saturn just look like a little brown ball, no rings at all. I've highlighted a particular moon in this picture called Titan. It's Saturn's largest moon. It has a very dense atmosphere, which is unique among all the moons in the solar system. One of the most fascinating things about Titan is that it looks like the boundary waters, kind of on a larger scale with bigger lakes. But these are all enormous lakes, Ligia Mare, Punga Mare, Kraken Mare, dozens and dozens of these lakes. And they look like in this image, like they're filled with water, but they are not. It is cold out here at Titan. It's about 290 degrees below zero. That's the temperature it is if you're walking around. So quite a bit colder than Minnesota. And those lakes, therefore, are not filled with water, but instead they're filled with liquid hydrocarbons, methane and ethane. If you get a pump in there, you could power everything with all of the liquid. That's just fuel, in a sense, waiting to be used. You could attempt to swim in one of these lakes, and if you did, you would float because it has kind of a different density than water. So I like to envision in the future, perhaps astronauts kind of floating and swimming the way you would on a salt lake, for instance. So yes, there are lakes on Titan, and I believe it's Ligia Mare, that lake, that's about as big as Lake Superior. So there's a lot of methane, cold methane lakes up on that little moon. We landed a craft there, and I thought you'd just like to see what it looked like. It's not a very high resolution video, but it shows a little spacecraft in the early 2000s that landed on the moon and took measurements called Huygens. And you see in the foreground those white bouldery things. They've probably been eroded because they've been tumbled along a stream and a river. It has a whole atmospheric system, just like the Earth, but not built on water vapor, instead methane vapor. And those rocks are made out of water ice, as far as we know. And they're as hard as concrete because it's so doggone cold there. If you like ravioli, and I know I like ravioli, you might be interested in pictures of Pan. This is one of Saturn's small moons. It's only 22 miles across, and it orbits around the planet within the ring system. And as it does, it collects and gathers the smaller particles in the ring that have formed sort of a crust or its own little ring around the moon. You can see it here. Isn't that fascinating? Only 22 miles across. So you can kind of picture how big this is. We call that the ravioli moon. It's named Pan after I believe that's the Greek god. So we've looked at Venus, we've seen how hot it is and learned a little bit why. We've seen Saturn and studied its rings, learned they're made out of water ice, a very common thing that we find here on Earth. The next planet in the evening sky is off way in the east. So we turn ourselves away from the sun direction and look east. And I bet a lot of you have seen this brilliant planet. I don't care where you are. You could be in downtown Minneapolis or downtown Los Angeles. You can still see Jupiter. It's in the constellation of Taurus, the Bull. This is a picture I took from my home just a few nights ago. And it shows Jupiter right up here. Here's the Hyades star cluster. And down below here is, yes, our favorite constellation, Orion the Hunter, or at least mine. It's what I think it is my favorite. Here's the 3 stars in a row that make the belt of Orion. I saw a thumbs up there. This is a star map showing you Jupiter. It's right here between the horns of the bull. You can see the bull's face. The Pleiades is in the shoulder of Taurus. The face is formed by the Hyades and Aldebaran, and there's Jupiter between the horns. And this is the view looking northeast tonight at 7:30, if it were clear. I don't know what it's like in the Twin Cities area or where you live, but we have clouds and snow here in Duluth. Jupiter is the biggest planet, 11 times the size of the Earth. No hard surface again, nothing to grip. You just put your hand right down there into the clouds, ammonia ice. It rotates really fast. Here on the Earth, a day lasts 24 hours. And Jupiter, under 10, about 9 hours and 57 minutes is a day on Jupiter. It's really fast. Right now, this week, Earth and Jupiter are lined up on the same side of the sun, which means they're closest together for the year. So they're under 400 million miles apart, close, as they say in astronomy. So that's why, one of the reasons why Jupiter looks so bright to your eye right now. It gets very high in the sky because the constellation Taurus is in a place in the zodiac where the sun is in May and June. So in May and June, the sun is really up there. So that's why Jupiter is really high up there, especially as it gets later and later at night. So it really beams down on you. Here are some incredible orbital views of the planet. This place, the extremely windy planet. There's winds that exceed typically 300 miles an hour, 400 miles per hour. Those little whirls, those vortices that you see, those represent storms. These storms here, these little whirls are about the size, each of them, about the size of the United States. And they're concentrated in the polar regions, but you'll see them all over the planet. This is a photograph taken by the Juno spacecraft from NASA. The spacecraft is still orbiting and sending pictures. Anytime you want to see more pictures, just do a Google search, just type in Juno Jupiter, and you'll spend an hour at your computer. Wonderful vortex here you can see in one of those storms, powerful winds. There's a lot of heat coming up from the interior of Jupiter, and that's part of the reason and the cause for these storms. Jupiter, it's so massive, it's still collapsing inside and producing heat since the day it formed at the start, at the beginning of the solar system. Oh, who doesn't? You probably are familiar with the red spot. This is the largest storm on the planet. Although it has been shrinking in recent decades, it's about as big as the Earth, a little bit bigger. And there's interesting chemistry going on in it that give it a red color. There might be phosphorus involved or other elements that are kind of welling up from beneath and causing chemical reactions that give it that amazing red color. Right now, through a telescope, the red spot is pink. It changes color depending upon chemistry and what's in it, what's mixing up in there. I just looked at it last week and I thought, that really looks pink. Here's a wonderful thing you can do with the planet is put a pair of binoculars on it. So when you identify Jupiter there in the eastern sky, as soon as it gets dark, you see it climbing through the night, just point your binoculars at it. Try to steady them though if you can. I like to put mine on, I open a car door sometimes and I just rest them on the roof of the car and look up. And if you focus sharply, you will see up to 4 little tiny lights right next to the planet in a line. And those are its four brightest moons, or largest moons too: Io, Europa, Ganymede, and Callisto. We have a mission that's headed for Europa right now, the Europa Clipper. Io is fascinating because it has more active volcanoes than any place else in the solar system. There's all kinds of fascinating things about each one of these, and you can see them in a pair of binoculars. To follow the outer planets, especially Jupiter and Saturn, you have to kind of keep an eye on them, because the problem with planets, all of them, is that they're always moving, right? Because every one of them is orbiting the sun. So you have to keep tabs on them in various ways that I'll show you in a moment. But for now, we're going to compare Jupiter and Saturn, remembering that a planet's speed decreases as its distance from the sun increases. So if you look here, you can see Mercury is moving. Wow, that thing is going at 107,000 miles per hour, really fast. So a year takes 88 days. You get to Jupiter, 29.9. You get to Saturn, it's moving at a fifth of Mercury's speed at 20,000. Notice Jupiter's speed again: 30,000 miles an hour, takes 12 years to go around the sun. Saturn, around 20,000 miles an hour, so it takes 29 years to go around the sun. You can see them orbiting the sun if you identify them, let's say this year, and then keep an eye on them. And by next year at the same time, you'll see how much each planet has moved eastward in the sky along its orbit. And this is what you'll see. Here's Aquarius, here's Saturn right now, 2024. 1 year from now, it'll be there. And now you know why. It's because it's orbiting. And in 1 year, that's how much Saturn moves. It takes about 2 to 3 years for Saturn to move through move through one constellation of the zodiac. Jupiter takes 12 years. So there are 12 zodiac constellations. So it spends 1 year apiece, roughly, in each constellation of the zodiac. Look at how much more it moves in a year. Next year, it'll be in Gemini. Huge amount compared to Saturn. And that's because it's closer to the sun. So that's one of the tricks or keys in tracking planets, is to know that each has its own motion and period, and to get familiar with where they are now, and to keep kind of watching them. All right, we got another evening planet. This one you have to stay up just a little bit later for, and it is Mars. This is looking east, 9:30 p.m. Right now in December. You may want to wait if you got buildings, tall trees. You may want to wait till 10 o'clock this time of the month to look at it. But boy, you will see. Here's Jupiter, right? And then you slide down towards the east and you see these two bright stars vertical. That's Castor and Pollux. Keep going, wham, you're going to hit Mars. Can't mistake it for anything else. It's really bright and it's really orange red. So we know that familiar Mars color. It almost looks fiery to me. Mars will be closest to the Earth. It's closest in 2 years, and it's brightest next month. So it's coming up on that time. So it's already bright. It's only about twice as big as our moon. It's a small rocky planet. Day length there, almost identical to the Earth. Average daytime temperature, very similar to Duluth, 81 degrees below zero. There are exceptions. The nighttime temperature, though, really can get down there, 100 below. And at the poles, it can go quite a bit colder than that. One of the things we love about Mars and fascinates us is the fact that it has lots of signs of having been wet in the past. Here's a view of the South Polar Cap. That's ice you're looking at there. It has a cap made of frozen carbon dioxide, dry ice, basically. When that vaporizes away, it exposes water ice. So you could get your skis out someday and get on that cap and do a little shushing out there on the Martian South Polar Cap. There are pictures, I could show you dozens and dozens, that show ancient rivers cut into this landscape. There are glaciers on Mars. There's all kinds of evidence of water having been there, having flowed, there are evidence of lakes, even an ocean. Here's a view And these pictures are available to anybody that ever wants to go online and just take a look. I'll show you how in a moment. We have two active rovers right now on the planet. There's the Curiosity rover. It's currently in Cadiz Valley. This is from November 2nd. Look at that environment. Can't you just imagine walking on those rocks? This would be a perfect rover trip, to go to this valley on Mars and head over to the hills there in the distance. And here is a picture that was taken by the Perseverance rover. This is the more recent landing on Mars. The first rover, Curiosity, is looking for environments that could potentially be places where you might expect life to form. And it has found those environments. This one, Perseverance, is sampling all kinds of places in a spot that used to be an ancient delta and river. And it takes all the samples and it stores them within the rover itself. But as a backup, it takes additional samples, and each one is named, and it's dropped them on the surface. So that's what these represent. These are all little tubes like this. So if something happens in the future, we can't get in the rover to retrieve those samples because we're going to send a spacecraft in the 2030s to do this, then we can go to these other places and pick them up on the ground. It's the backup. I love this photo. This is taken by Perseverance. You can see the rocks and the sandiness of the landscape, but it also shows the sun. Mars being about twice as far from the sun as we are, the sun is small in the sky, and you get a sense in this photo that the sun is maybe only about half as big as we'd see it on the Earth. So anyway, this is just a cool rock. I like cool rocks. When I go out on my hikes, I'm always picking up rocks. Perseverance found this striped rock on September 13th. It appears could be metamorphic. We don't know exactly what it is yet, but it's being analyzed. So you never know. They found meteorites on Mars too. And if you ever want to look at more images from either rover, every day there are dozens of new images posted. They're all raw. And this one's a raw image, for instance. They're posted. Just Google Perseverance raw images or Curiosity raw images. And it's just a bounty of things that you can scan through to get a real feel for what it's like to be on this somewhat Earth-like planet. Just a heck of a lot drier and colder. Mars, if you don't know where it is or have trouble finding it, and you luck out and it's clear on December the 17th, the waning gibbous moon will park right alongside that bright yellow or bright red planet. It's in the constellation of Cancer the Crab, very faint constellation, but Mars really lights up the scene. In the early morning hours, it will be very close to the moon. The moon's gradually moving in its orbit, so the two will be right next to each other in binoculars. It should be a great sight with the eye. And here's the additional bonus planet I wanted to add at the end of this month, the planet Mercury, another inner planet, innermost planet actually, that will be out in the morning sky in twilight. If you're out there running, let's say, because I imagine some of you are runners, you can see the waning crescent moon. To its left is Antares, a reddish star, and if you keep going, you're going to hit Mercury. So it's possible this month to see all the bright planets: Venus, Saturn, Jupiter, Mars in the evening, and then Mercury in the morning. Of course, Uranus and Neptune, they're up there too, but you need binoculars or a small telescope for those guys. A couple final things. Besides the planets this month, I want to be sure to let you know that we have the richest meteor shower of the year occurring. It's called the Geminids. Some of you might be familiar with it already. Happens to peak on the night of December the 13th and 14th. Now, unfortunately, we've got a bright moon. You can see right here. I put an exclamation point next to it even. We've got a bright moon, and a bright moon tends to blank out those fainter meteors. But this shower is so rich, you just get yourself in a lawn chair. I like to use one of those recliners, and I put my warmest coat on and warmest pants and boots, and I get underneath a wool blanket, and I just lay out there and wait to see what happens. You never know when they're going to come. Sometimes you have to wait 5 minutes and nothing happens. And then boom, you get one. And then two happen at the same time. So it's a wonderful shower. So I hope it's clear that night because I sure want to come out and view it. They will appear to radiate from a spot in the constellation Gemini. So that's why they're called Geminids. And that spot is called the radiant. And there's Mars right below it, as you saw in the other. So we have Mars and Jupiter, and we got some Geminids too. This is the proper meteor. I described it, but this is kind of what it looks like. She was perfect. That's my daughter. She was perfectly comfortable. She joined me for a Gemini meteor shower a couple of years back. So that's Katie. There are unexpected joys of being out. Although nowadays we have a lot of forecasts, you can kind of anticipate the northern lights. Still, sometimes it does not come when you expect it, and it'll arrive when you don't expect it. And that to me is one of those unexpected joys of being out and seeing the northern lights turn into something a whole lot more amazing than you had anticipated. And that happened on this night. This was back in early October, not the October 10th storm. This happened a few nights prior. And the whole sky at 1 a.m. just like exploded. About made me cry. It was incredible. So here's some resources for you because you're like, well, how am I going to find these things and keep track of this stuff? You can get this. This is free at skymaps.com. Free monthly paper star map. It's a PDF. Download it, print it out. Best thing about it, okay, it has a map, shows you the whole sky here, flattened out into a pancake. The center is the overhead point, and the edge is the horizon. So you have 360 degrees, and then the overhead. Over here on the left is the calendar. So it will alert you to whatever interesting naked eye events are happening in the coming month. I also recommend a stargazing app. If you don't have one, I recommend the Stellarium mobile app for Android or iPhone. Just Google Stellarium mobile and download this thing. It automatically knows where you're at if you allow it. And then you hold it up to the sky. You put it in night mode. Night mode makes everything kind of red, as you see right here. And you move it around and it shows you a live view of the sky. So if you see something you don't know what it is, you can put your phone over it and then see where it is and tap it, and it'll tell you the name and other information. And finally, this is fun. When it's cloudy, the Stellarium app is also on the web. So it's at stellarium-web.org. You go here, and it's an interactive sky map where you could just use your mouse to click around and scroll to zoom in and out. You can locate galaxies, and it will show you the sky for wherever you are and also at whatever time you choose. That's true with the app as well. So this is really a delightful thing. If any of you are teachers and want to share with children how to learn about the sky, this is the spot to do it. The Stellarium Web Online Star Map. So just a final thought. We know this is the coldest time of year. I know a lot of my amateur astronomer friends don't even bother to go out and observe with their telescopes. It's just like, nope, 32 degrees, I'm done. But I really encourage you to go out. One of the things that's really nice about the winter, when you dress properly, is how quiet it is. I love the silence. And so even when it's below zero, I'll pull my hat off, my bomber hat, just listen to the almost painful silence. There's such a joy in that quietude. So I like that. Except, of course, sometimes you hear the trees snapping, when the temperature drops below zero, they'll pop and fire off, as the sap freezes. So that just makes it more wintry. So I love that. And the second greatest joy of being out there and freezing and enjoying the stars and the silence and locating all the planets is the pleasure of walking back inside your house. And if you've got a wood stove, this is my wood stove here. If I got a wood fire going, oh my God, the joy of warming up is one of the best things about winter night sky observing, whatever form of heating you like. So there's always that waiting for you. And with that, that's the end of my presentation. I'm not sure if there's a question and answer, but if there is, I'm certainly here to help out.
We have a question in the chat. So Lillian is wondering, what kind of starter telescope would you recommend for a rookie?
Oh boy, I would recommend there is something called a 6-inch Skywatcher. Dobbs, well, we'll just call it it's you can type in on a Google search 6-inch Skywatcher. That's the name of the telescope. And look up the information on it. I've seen some pretty good sales on them lately, what with the Cyber Monday thing and the seasonal stuff. So the 6-inch Skywatcher is very nice. They also make a little smaller one that's even more affordable. I believe it's a 4.5-inch Skywatcher. And then one other scope you can look at, probably about 250 for this one, is a Celestron Star Sense, like sense as in senses, Star Sense telescope. And on this scope, you attach your smartphone and use the software that comes with it. And all you need to do is turn the telescope and use your smartphone screen, and it will tell you when you arrive at the target that you've selected. So you don't have to do any of this looking. So Celestron Star Sense or one of the smaller Skywatchers. And then a good pair of binoculars. I mean, don't overlook that. I bet a lot of you have those, but they're great for things like the Pleiades star cluster. You'll see so many more stars. They're great for the Hyades. You'll see Jupiter's moons. Wonderful for eclipses. We have a total eclipse of the moon coming in March. I mean, those are good for that. So binoculars are most useful. Anything else?
Bob, we have someone who's actually listening to us from Florida, and she is
Oh,
wondering whether the Geminids will be visible from Florida this year, and
yes.
whether it'll be December or January.
It's all the same around the world. Even people in the southern hemisphere can see the Geminids to some degree, not as well as the northern hemisphere, because it's in the northern sky more, or up high towards the north. But perfectly fine. You're in a great spot in Florida because Gemini, for you in Florida, is even higher in the sky than it is for us, which means there is nothing blocking, no horizon, nothing blocking the view of any meteors that you might see. Again, it's that bright moon that'll get in the way for all of us. So one recommendation I have, you can look in any direction you choose, but when you're in that chair spread out, just put the moon behind you so that you're not looking at that glare, so it doesn't glare your eyes. And that'll help you see more meteors. And they do appear anywhere in the sky, so you can look in any direction.
I guess I missed what you were talking about with seeing Saturn and the rings. What kind of a telescope would you need for that?
For that, any of those scopes that I mentioned would easily show Saturn and its rings. If you have a spotting scope that can magnify like 40 times, you should also be able to see Saturn's rings.
Hmm.
But remember, in March, they're edge on. So right now, they're just narrowly tipped. So it's a fascinating view. It won't look like that big Hubble view where they're wide open. Whatever
Yeah.
scope you use, you'll see what looks like a shish kebab. It'll look like a ball or something with a stick through it. So
Hmm.
it'll look very unusual. And then if you keep watching Saturn, let's say you make a habit of this, you look at it next year and the year after, you're gradually going to see those rings tip open over time until they're fully open in another 15 years or another 8 years it takes for it to fully open. It's a
So
slow
Saturn
cycle.
is not a solid planet.
It's
Right.
solid in its very core, but the
Oh,
part that we see is all gas and ammonia ice clouds, basically clouds made out of ammonia ice crystals. So it doesn't have a solid surface. You're correct.
um,
And the rings, actually, of all the things that are solid, the rings are more solid because they're made out of actual chunks of water ice. We just can't see the pieces because they're so tiny and we're
Yeah.
looking from so far away. Yeah, it's a wonderful planet. So yeah,
Fascinating.
it's really cool to see a stick through a ball is what it looks like now. Mars, you need higher magnification, but in January, even a small telescope will show there's clouds right now over the north polar cap of the planet. In January and February, those clouds will dissipate, and you'll look at it in the telescope and you'll see a little white dot there. And what you're actually seeing is the north polar cap of dry ice and water ice. And that is such a cool thing because it looks a little like Earth because we have polar caps too. And Jupiter will show the belts in a small telescope, and it will easily show all four moons in any telescope you might have, or in any spotting scope for that matter.
Her chat was,
Oh, does she have it in the chat?
do you host MR outings certain times of the year? But I don't know what an MR outing is.
Minnesota rover.
Oh. Oh,
Is
okay.
that
Oh, maybe. Yeah, maybe. Wow, of course.
that's all right. Um,
I'll answer that. We don't have any program to do it, but you could post one, Liz, and I'm sure people would join you.
is that what she
think
means?
was
Like
wondering.
sorry,
I think she was
I am
wondering about
doing one in
starting that.
I'm doing one in Duluth. It's the St. Louis River Walk that's coming up later this month.
Oh,
But yeah, I mean, I think walking and talking about stars is a wonderful idea. I haven't done that much. I do more public observing, but I think it's really good. It's a great idea.
if you send me information about your hike, I can send it out to our rovers group.
Oh, I can do that. Yeah, yeah. It's again,
For
it's
the
just
people
like
who
right
are,
after dinner on the St. Louis River on the pathway here in Duluth, and we're going to talk about the stars that are visible and the bright planets, and also light pollution. You know, the issue of light pollution and its effects and how to help mitigate it. Because that's always such a thing, you know,
There
nowadays.
are rovers. There are rovers in Duluth here.
Oh, okay, great.
Yeah.
Is that you, Greg? Are you a
I
rover?
am. That's why I sound so much closer, I'm sure.
Yes, you are very crisp. I can hear you clearly.
Yes.
And to answer your question again, Liz, someone had posted, you may not have seen it or chatted, that we do have a rover member that regularly posts all different types of star and sky viewing stuff, regularly trips for that.
Would that be Suresh
It would
Srinivasan?
be.
Yep. I know Suresh very well, so
I'm not surprised.
he's a good guy, and he's really aware of all the stuff that's happening, and quite the astrophotographer as well.
Right. And he's got some dang good telescopic equipment that is a wonder to use.
Yes, dang good is correct.
So, Suresh, is he also from Duluth area?
No, he's
And does he post on the regular outings site?
He does post on the regular outings. He does live here in the Twin Cities.
Okay.
Well, Bob, thank you.
Thanks for having
Very
me. It was
interesting.
fun.
And thank you so much, Bob. We've got several comments in the chat thanking you and saying how wonderful it was. So thank you so
Yes.
much.
Well, thanks, guys. I appreciate it. It's a wonderful opportunity, and Stacy, thank you for offering it.
Yeah.
Absolutely.
You get bigger invitations from radio and whatnot, and we really appreciate you coming and doing an individual thing with our group. It's special, and I know that.
Oh, my pleasure. And you know, I relate to people that like to walk. I'm a rover at heart, trust me. The word applies. So thank you all.
Thank you.
Thank you.
And clear skies to you all too. I hope you get to see these planets and enjoy them.
Thanks for watching this Minnesota Rovers presentation. If you want to see more, please click on the link to our channel or the subscribe button below. Thank you.